Welcome to TechniCal, a bi-coastal podcast where Silicon Alley meets Silicon Valley. This is a podcast for technology professionals, so we go pretty deep. I'm your host, Bill Kozel of Tech Writers NYC. At Tech Writers NYC, we translate geek speak. Visit us at techwriters.nyc. My guests today are from the fog computing community, and I'm delighted to have them on the program. Lynne Canavan is Vice President of Marketing for the OpenFog Consortium, a global not-for-profit organization founded in 2015. She also serves as Executive Co-Chair of Fog World Congress. Rhonda Dirvin is Director of IoT and Embedded at ARM Limited, a UK-based company that produces a wide range of microprocessor IP for applications such as automotive, healthcare, artificial intelligence, and IoT. Matt Vasey is Director, IoT Business Development for Microsoft, where he focuses on expanding the ecosystem of technology partners, standards bodies, and innovation enablers. He also represents Microsoft as a spokesperson to the press and the analyst community. Full disclosure, none of these people are from New York or California, so we are invoking our phrase, the vast expanse in between. Welcome to TechniCal, one and all.
Thanks, Bill. It's a pleasure to be here.
Thanks, Bill.
We look forward to participating today.
Lynne, let's start with you. Why don't you tell us what fog computing is and why it should matter to our listeners?
Yeah, actually, it's interesting that you started off by saying that, we're not from California or New York, but the vast, surrounding areas. When we think about fog, that's exactly what it is. Fog computing is it's a system level horizontal architecture that distributes necessary resources and services necessary for advanced digital applications and brings them closer to the users and anywhere along the cloud to things continuum. So again, not a direct, if you think about fog, we're not a direct city to city connection, but it's all the space in between. When you think about these advanced digital applications, fog is first and foremost, it's an emerging architecture. It's a horizontal architecture that allows IoT, 5G, and AI, embedded AI applications to work as necessary. And the reason that we need fog is because today there is just so much data. There's terabits of data everywhere, streaming applications everywhere, and the existing systems just simply can't accommodate the amount of data in the necessary time with the necessary security levels and so forth. So fog is this architecture that works, again, along this continuum between the devices, the things, and the cloud. It works with cloud to make cloud more effective, more efficient, and it delivers the necessary latency, security, privacy, and decision-making control more locally to where it's necessary to have these applications perform.
Well, Bill, if I could add on one thing to what you said, I think the second part of your question of why should it matter to your listeners, I think because it's a new technology, I think it's going to open up a lot of other business models and businesses that haven't been there before. So I think it's a bit of a change in the industry, and anytime there's a change, that opens new opportunities. And so it would be good for some of your listeners to put some of their brain power toward how they could utilize that and create some new businesses.
Most of our listeners will be using fog for manufacturing and production systems. How would they go about setting up a fog environment, and what are the economics?
So I'll take the first stab at that. We had commissioned some research from 451 Research in terms of the size and the scope of fog, and certainly fog in manufacturing environments is very high up in terms of where we see the demand coming.
Yeah, I think I'll take and answer your question. I'm actually interested in what Matt's answer is, but how you go about setting up a fog environment today and what the economies are today. Today, one of the reasons that the OpenFog Consortium got started was we wanted to make an interoperable way to be able to do that so that customers wouldn't be locked into any one vendor and that the whole market would take off more quickly. We're not quite there yet. So today you would have to find one of the vendors, and some of them are members of our consortium that have products that exist in that space, but we're not quite to the point where things are interoperable today.
Yeah, what are the standards available in FOG?
When you think about manufacturing and the kind of digital transformation of manufacturing, most people look to the Industry 4.0 work that has occurred in Europe and is being adopted in other parts of the world as well. The precepts of the Industry 4.0 is really around digitizing the means of production and taking those means of production and connecting them in near real time to things like supply chain and manufacturing execution systems to allow, not just digitally transform, but really agile production. And so when we think about, fog and OpenFog in that context, we enable those systems that traditionally would run on, kind of a real-time service bus or a field bus, and those devices were all operating right at the edge. Enabling a continuum of intelligence from those edge devices all the way back up to middle tier devices, whether they be gateways or local processing, all the way up to the cloud, enables that transformation from, kind of the old model of manufacturing to Industry 4.0. Okay. The standards that are important there are standards like the OPC Foundation's OPC UA standard, which enables devices to be discoverable, to communicate with one another, to understand kind of the resource pool at the edge. And so that's an area where we have liaison with that organization. We're also working very closely with IEEE to develop some of the standards for orchestrating workloads at and near the edge. And so all that will accrete value to Industry 4.0 and to our customers that are looking to digitize the means of production.
Fog isn't just limited to factory environments. It also includes the use of drones, autonomous vehicles, and other devices. In those cases, where are the edge devices located?
So I'll start with in on this one. As Lynn said earlier, fog is a horizontal technology, so it crosses lots of different use cases. And on the website, we've actually articulated a number of these use cases. One of the interesting ones is drones. And so fog is not just about, edge devices just being in one particular place. Fog is about using the continuum of the compute power that exists between the edge and all the way up and through the cloud. So one of the cool things about fog is that the edge and the fog computing nodes can change and move throughout location. So one of the other use cases that's on there is a video streaming application that talks about the Tour de France. And so if you think about that race moving through the country of France and the different needs that it has along the way and being able to utilize different computing points throughout the country as the race moves, it's a really interesting use case. So it's not static, it's dynamic, and it moves as the use case needs it to move.
So it's on the vehicle or the drone itself then, and it uploads to the cloud, or
no? So it can use the nodes in the network infrastructure. So as the network infrastructure has gone from being hardware specific, made for that particular use, software defined networking has actually made that be a more generic hardware. And with the use of containerization on a lot of those nodes, you can actually reuse the computing and storage and networking power that are there for other applications when it's not being used for networking. So it frees up a lot of compute. And the trick is to allocate the workload across those different computing nodes that can be there.
I see.
The other. Go ahead. Go ahead, Matt.
To emphasize that point, it's the flexibility that is one of the powerful features about fog. So that if you have a sudden ramp up in demand, or you need a lot of control, you need a lot of bursts of compute time, you can take these networks of fog nodes and allocate different resources to the specific need right away.
And Matt?
The other thing to think about when you the question about where the edge device is located, and in the old model we used to think about there's the edge and then there's the cloud, and fog really talks to this continuum idea where you have intelligence at the edge, at the near edge, and up through the network topology all the way to the cloud. When you think about something like an autonomous vehicle, where there are 50 or more microprocessors inside a vehicle, in fact, I've heard counts much higher than that. The car itself is a fog where you have parts of the car that have GPU or FPGA acceleration in the car for doing certain kinds of high-speed processing. You have cloud-connected processes as well, and so that car is in fact has edge devices, which might just be a sensor right on a brake pad, all the way up to processing units that might be just adjacent to wheel well, or when you get into that kind of main processing unit, and then all of that kind of backhaul to the cloud. And so the car itself in that model is very much a traveling fog or a traveling data center within that whole context of the fog. So I think the concept of edge versus cloud is being really changed into thinking about this idea of a continuum, which is really what the FOG Consortium has been proposing for the last couple of years.
And how does artificial intelligence factor into FOG?
So we consider AI to be an application that FOG enables. So again, we have the compute, the control, and so forth. So you basically can bring cognition much closer to where the devices are and enable AI. So we think of FOG as the architecture that allows for this embedded AI to happen as rapidly as it's required. And there's a lot, we see this as one of the emerging killer apps for FOG. Certainly IoT is an app, 5G, but certainly embedded AI really requires that, because you've got all the tremendous amount of data, the need for sub-millisecond latency to process all those applications and so forth. And FOG has that, the architecture enables that to happen.
And to build on what Lynn said a little bit, that architecture and the discoverability of resources in the fog enables AI or artificial intelligence to operate without the latency of the cloud. So it can actually look across the edge or the near edge and understand where there's the right hardware acceleration to run a process. So if you're a camera and you're looking to have do object recognition, and the camera doesn't have the right kind of processing or enough processing to meet the SLA of the application, you can look to the near edge and say, where is there a resource that can help my workload accelerate, rather than having to do the backhaul, which might be 300 milliseconds or more to get to a cloud compute, and you can leverage that kind of near edge compute, which is made available by the orchestration that we're building in the FOG Consortium.
Will fog computing be one of the first use cases for 5G?
Well, fog computing is a horizontal technology, and it will help enable 5G, but I would actually turn it around and say 5G might be a use case that utilizes OpenFog.
Okay.
Yeah, I have to agree with Rhonda there. I think 5G does a couple of things that are interesting. Obviously, the ability to move huge amounts of data quickly, and the reduced latency. The latency is going to get down. Like operator networks frequently have 10 millisecond latency, and 5G is proposing to be down to 1 millisecond latency. And then finally, device density that 5G enables, where you can have hypothetically 1 million devices per square kilometer, whereas today we're into the tens of thousands per square kilometer. Those magnitude shifts in capability of the network are going to enable fog to be even more useful, especially when devices can communicate near the edge with those kinds of low latencies, high throughput, and density.
Rhonda, does ARM create chips that are specifically designed for fog computing?
So we don't create chips, but we create microprocessor IP. So the answer is, it's an applicable question, but the answer is no. We don't create chips specifically for fog computing. So what we do is, because we create the microprocessor IP. Our partners take that IP and they put special functions around it. So they might have some expertise in automotive and be able to do make extended temperature chips, or they might be in really ultra small, ultra low power process technology, and so they make chips specific for IoT, right? But for fog computing, we have a number of our higher performing chips that are typically used in edge nodes, and it's our partners that take that and put their particular storage capability or interconnect capability or in and out capability of the chip, and then make that available that's applicable for fog computing. So we don't have things that are unique to that, but we have a lot of things that apply to that.
I see. And Matt, what role does Microsoft play in establishing a fog environment?
Yeah, that's a good question. We get that a lot. I mean, I think when I think about the value that Microsoft brings to bear in the fog environment, I think about three main pillars: IoT tools, standards, and AI in general. And so when I think about IoT tools, we have capabilities in the cloud, capabilities like Azure's IoT offering, which is an infrastructure offering. We have SaaS offerings like IoT Central, which provides the ability to connect devices very quickly and get insight from them immediately. We have platform as a service offerings, Azure IoT Suite. And then finally, we deliver value at the edge, which Azure IoT Edge, which is which enables you to take processes that would normally run in the cloud and push them right down to an edge or near edge device. So that's our IoT tools offerings in summary. The second pillar is really around standards, and so we've worked very closely as founder, along with ARM and Intel and Cisco and others, created the OpenFog Consortium to really start the conversation, start driving standardization, and de-risk the proposition of fog for our customers. We work with standards bodies like the OPC Foundation to help organizations connect edge devices and understand the semantic models that those devices, or provide semantic models that allow those devices to do self-discovery and to interoperate. And then finally, work with groups like the IIC and OMG and IEEE. We really try to de-risk the path from the old computing models to the new computing models. And then finally, the third pillar is really AI, or artificial intelligence, and we think about artificial intelligence as a way to enhance the people that are involved in processes, as well as enhancing the processes. And we provide tools, whether they be kind of API-based services for developers, or deep tools and frameworks that enable advanced, machine learning, deep learning, and AI to live, in the cloud as well as near the edge. And so when we think about how we help customers build their fog environments, we think we provide a full suite, tools, standards, and AI.
Okay, Lynn, what is the OpenFog Consortium and what is its mission?
So OpenFog is a global nonprofit organization that is working to create an open and interoperable reference architecture for fog computing. So basically the technology that we've been describing is how does it all work and how will it work seamlessly within systems. Again, you've got a horizontal architecture. So we have about 65 member organizations that are working together in these collaborative work groups to define what the necessary requirements are for this architecture. We were founded in 2015 by ARM, Cisco, Dell, Intel, Microsoft, and Princeton University, and have come together. Again, one of the things that we pride ourselves on is the fact that we have researchers working with very large companies and a lot of startups working together to solve this problem, because we do think that fog is big and it can't be proprietary. It has to be open and it has to be interoperable. We also do some education around fog, and would also like to invite your listeners to kind of follow us along on our website, openfogconsortium.org. And also we have an event called Fog World Congress that's going to take place October 1st through the 3rd in San Francisco. So that is a great place to learn about cloud computing, the technology, the industry applications, and the innovation that's coming from that.
Two of the things that are unique about the OpenFog Consortium itself is, number one, we invite in academia. So we really are trying to leverage the research and the study that some of the universities are doing around this new concept. Mm-hmm. And the other thing is we have some regional committees. So we have very active regional committees in both Japan and China. They see the benefit of fog computing and of working together. And so they have contributed greatly in terms of use cases and ideas for interoperability testing and interoperability test labs. So I think those are two things that are a bit different about the consortium that might be interesting.
Well, Lynne, Rhonda, Matt, thank you for being on Technical.
Thanks for having us.
Sure.
Thank you, Bill.
Thanks, Bill.
For more, visit openfogconsortium.org, where you'll find a wealth of resources, including white papers, webinars, videos, and a fog blog. Also, visit arm.com and microsoft.com for more on their products and services. That's it for this edition of Technical. Technical is a production of TechWriters NYC. For Technical and TechWriters NYC, I'm Bill Kozel. See you next time.